Alright, boys and girls, this is your 4.6 homework examples. It's 4.6, we're doing counting techniques and using those counting techniques to find probability. So here's a question: find the probability of winning a lottery with the following rule. You select 5 of the winning numbers from 1 to 43. Okay, so they're going to have 43 balls in a little spinning thing or whatever. They shoot out, and then you have to pick 5 of them. So in any order, no repeats. Okay, so for it to be in any order, no repeats, that means we're going to use combinations. Okay, so if you recall from your notes, NCR is what we're being asked to do here. NCR is equal to n factorial divided by n minus r factorial times r factorial. Alright, so in this case, n is the number of numbers we're selecting from, so that's 43 factorial. And then n minus r is 43 minus 5. Alright, 43 minus 5 is 38 factorial. And then r is 5. So that's 5 factorial. Okay, and then if you write this out, 43 times 42 times 41 times 40 times 39, and then after that you get 38 factorial. Okay, and since that's the denominator down here, then we can cancel that out, and that's why I'm writing it as 38 factorial instead of dot 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 down to 3, 2, 1. And then the bottom we got the 38 factorial that's getting ready to cancel, and the 5 factorial that I'm going to write as 5 times 4 times 3 times 2 and then times 1, even though the times 1 doesn't matter. Okay, the 38 factorial cancels, and then 5 times 4 times 2, 5 times 4 is 20 times 2 is 40, so I'm going to have all of those cancel with the 40. Alright, and then 3 will go into 39 13 times. So now the entire denominator is just down to 1, and this is what's left on the numerator. That's my total number of ways that this can happen. Alright, so I bring up my calculator, and then I'm going to multiply out 43 times 42 times 41 times 13. Okay, so I get 962,598. Alright, and then if I'm going to win the lottery, I purchase one ticket out of this many chances. So the answer to the question is 1 out of that. Alright, now this one goes a little bit further. It says, alright, if we went 1 through 25 rather than 43, the chances of winning is 1 in that. Okay, so again, it's if I did 25, choose 5, I'd get this number. Alright, what's the probability of winning if the rules are changed so you have to have them in the same order? Well, now it's 25 P5. Okay, because now we have to get the order right and the numbers right. So recall that n PR is simply n factorial over just n minus r factorial. There's no r factorial in addition to that in the denominator. So because the denominator is smaller, the overall number is going to be bigger. So this is just 25 factorial divided by 25 minus 5. Alright, that's n, that's r. 25 minus 5. So that's 20 factorial. And then if we multiply that out, just like we did before, 25 Alright, we get this, and then the 20 factorial and the 20 factorial cancel, and I'm left with just this. Now there's no other r factorial that I have to split apart and cancel some of these out, so it's just what's remaining up there. So that's going to be 25 times 24 all the way down to times 21, and then I get 600 or 6,375,600. Alright, and then again, the answer is, what's the probability? So now it's 1 out of that number. Again, assuming we've only bought one ticket here. Alright, so remember, permutations, the order matters. Combinations, the order doesn't matter. Now, just to show you, both of these I could have done with my calculator. So on your calculator, we have the NCR button and the NPR button. So if you press the math button here and then come over to PRB, it's easiest to just press left instead of having to press right. And then there's NCR and there's NPR. For this one we need NCR because the order didn't matter. Oops. You need to put your number in first. So 43, that's our N. Then math, PRB, NCR is option 3. Alright, and then how many we're choosing? We're choosing 5 at a time. Alright, and then there's my denominator, 962, 598. Alright, and then come down to this one. Now this is 25P5, so I put in the 25 first. Alright, and then go to NPR this time. That's option 2. And then 5 is my second number. Alright, and then there's our 6,375,600. Okay, so your calculator can compute those for you. I was just showing you how to do it via the formula, but there are those shortcuts on your calculator. Alright, now when you're dealing with these questions, same as the last two, you always have to ask yourself, does the order matter? Does the order matter for which one I'm using? Alright, so read this one. A certain company reduced its management staff from 14 down to 4. So they fired 4 managers. The company claimed the 10 managers that were randomly selected for job termination. So they just randomly selected them. However, the 10 managers chosen are the 10 oldest managers among the 14 that were employed. So answer these questions. Find the probability the 10 managers that are randomly selected from a group of 14 are the oldest 10 that are selected. Alright, so if you think about it, what we're being asked to do here is a classical probability, meaning we have to compute the number of ways the 10 oldest can be let go and divide that by the total number of ways that 10 people out of 14 can be let go. Well, the number of ways that 10 people out of 14 can be let go doesn't have anything to do with the order that they're let go in. So the denominator here is going to be an NCR combination. Alright, now this particular question, because of the oldest part of it, a lot of people want to confuse that with being NPR because there's an ordering to age. But it's not saying they were let go in the order of their age or anything like that. So this is going to be an NCR problem where our denominator is the total number of ways that we can let 14 people go. Let 10 people out of 14 go. So I'm going to use the calculator to get that denominator. That's 14 people, or how many we're choosing from, and we're letting go 10 of them. So that's NCR 10. So there's 1,001 ways that we can let 10 people go out of 14. So that's my denominator. Now, the question remains, what's the numerator? How many ways of these 1,001 do we let the 10 oldest people? Well, it's just one. It's the one that includes the 10 oldest. Okay, the order that we let them go in doesn't matter again, so it's just that group of 10. That's one of the possible groups of 10 of these 14. So there's a 1 out of 1,001 chance. And then part 2 says, is that low enough? Is that probability low enough to charge that instead of using random selection, they're just firing the oldest employees, trying to get the people making the most money out of the door? Well, if you take 1,001 as the denominator, 1 is the numerator, we get point 3 zeros and then 3 nines. So 0.000 and then 999. And remember, we're using as a rare event, we're using 0.05 as the probability of 0.05 as being rare. So this is extremely rare under the assumption that this was a random selection. So because it was a random selection, this is very unusual. Alright, again, this is going to test your ability to know when to use NCR and NPR. There's 27 members on the board of directors for a certain nonprofit institution. They want to select a chair, vice chair, a second vice chair, and a secretary. Alright, so they want to come up with 4 positions. How many different slates of candidates are possible? Well, because there's a ranking here, there's an ordering here, we need NPR for the first one. So we have 27 that we're choosing from, and we're going to select 1, 2, 3, 4 positions. So that's 27 in PR 4. So that's 421,200. Alright, and then part B says, what if they're just making a subcommittee of 4 members? Alright, a subcommittee that doesn't have a chair and a vice chair and a second vice chair. It just has 4 members. Alright, well now there's not an ordering, it's just 4 of the members. So if it's John, Paul, George, and Ringo versus Ringo, Paul, George, and John, it doesn't matter. That's the same subcommittee, so the order doesn't matter. So now that's a combination. That's an NCR. So I'm going to hit second enter. I'm going to go back to NPR and I'm going to press math, change that to NCR, and then now we're down to all the way to 17,550. Okay, so that's the difference between the two. Big difference in the number. We're talking about 400,000 versus 17,000. Alright, and then a basket contains 24 eggs, 8 of which are cracked. If we randomly select 10 of the eggs for hard boiling, what's the probability the following events occurs? All the cracked eggs are selected. Alright, so again, the denominator here is just how many we're selecting. So we're taking 24 eggs and choosing 10. We don't care cracked or not cracked. So the denominator here is 24, choose 10. Okay, the numerator, alright, all the cracked eggs are selected. Alright, there's 8 of these eggs that are cracked. Alright, we still got 10 eggs to go, or 2 eggs to go to get 10. So of the 8, we're going to choose all 8. So 8 choose 8. Alright, and then we're going to multiply that by how many eggs are left that are not cracked. So there's 24 minus 8, which is 16 uncracked eggs. Now, of those 16, we have to pick 2 to get to 10. So these 2 numbers right here are what's combining to this 10 right here. Okay, these other 2 numbers in the front are combining to the 24. Okay, cracked eggs, not cracked, the total. Alright, the cracked eggs we pick, the non-cracked eggs we picked, the total. So that's where all this stuff is coming from. Alright, now, when I go to my calculator, I can literally type it in just like this. Alright, I'm going to put it in parentheses just so you can see it. But 8, choose 8 times 16, choose 2. Alright, that's my numerator, and then divide by 24, choose 10. Alright, so this with 4 leading zeros, 0.0000, and then a 6. Is that right? Is it a 6? Yeah. Alright, so 6, I'm going to do 1, 2. I'm going to get 3 significant digits. Alright, so that's how we would do this. These two numbers add to 24. These two numbers have to add to how many eggs I'm choosing total. Alright, so total in the front, choosing in the back. Alright, part B. None of the cracked eggs are selected. So again, the total numbers is always going to be the same for these. 24, choose 10. Now we got 8 cracked eggs to choose from, but we're picking none. So that means the 10 eggs all come from this. Or sorry, the 10 eggs, not 10 cracked eggs. The 10 eggs chosen all come from uncracked. Alright, so again, I do the same thing. I'm going to hit second enter, bring back the last thing I did. I'm going to change the 8 here to a 0. Alright, and then I'm going to change that 2 to a 10. Do that, hit 1, and then second delete is insert. Now I can change that to a 0, and it pushes everything over. Okay, so we get now 0.004 to 3 significant digits. Oops, 0.00408 to 3 significant digits. Okay, and then part C, 2 of the cracked eggs are selected. So I got 8 cracked eggs. I choose 2 of them. I've got 16 uncracked eggs. I choose 8 of them. And again, we're still dividing by 24, choose 10. Alright, so once again, I'm going to hit second enter. Change this to 2. Change this to 8. So now I hit delete and an 8. Alright, then hit enter. So 0.184 to 3 significant digits. 0.184. Okay, so that's the process when you're making the selection, and there's 2 different types, and you're choosing a certain amount of each one to add up to some predefined total. All right, the predefined total here, 10. That's what the second numbers add up to. And again, if I go through here and you look at every single one of these second numbers, oops, and the second numbers all add up to 10. Alright, and then the first numbers are all adding up to 24. Alright, so that's some of your examples from this section. Email me if you have any questions.